Welcome to my channel, Amateur Radio Universe. Today in this video, I am going to talk about the tuned collector radio frequency amplifier. A tuned collector radio frequency amplifier is a circuit which is used in radio receivers to selectively amplify radio frequency signals. We will go through the parts of the circuit in detail and see how this functions. A tuned collector radio frequency amplifier is an amplifier that amplifies a particular narrow band of frequencies while rejecting all others. An amplifier that amplifies a specific frequency or a narrow band of frequencies is called a tuned amplifier. Here the resistive load in a broadband amplifier is replaced with a parallel tuned circuit whose impedance depends upon the frequency. It offers a high impedance at the resonant frequency and reduced impedance at all other frequencies. Functions of tuned collector RF amplifier. A tuned collector radio frequency amplifier is very selective and strongly amplifies the signals at the resonant frequency. This type of selective amplifiers are useful in radio receivers to select a radio frequency signal of a particular frequency from other radio signals of adjacent frequencies. The difference between a tuned amplifier and a broadband amplifier is that a tuned amplifier tunes the amplifier to a very narrow bandwidth. If the signal is of the same frequency as that of the resonant frequency of the LC tank circuit, a large amplification will result due to the high impedance of the LC circuit, which is tuned to the resonant frequency. The LC tank circuit tuned to the resonant frequency will selectively amplify the signals at the resonant frequency and reject all other frequencies. The amplification reduces as the frequency is moved towards the lower or higher side of the center frequency. Frequency of the parallel resonance circuit. The frequency at which the parallel resonance occurs is called the resonant frequency Fr. The resonant frequency of a tuned circuit is found out by the formula Fr equal to 1 by 2 pi the root of Lc, where Fr is the resonant frequency, L is the inductance of the coil in Henry, and C is the capacitance of the capacitor in Farad. Characteristics of parallel resonance circuit. 1. Impedance of the tuned circuit. The impedance offered by a parallel LC circuit is given by the equation supply voltage divided by the line current V by I. Since at resonance the line current is minimum, therefore the impedance is maximum at resonant frequency. The impedance rises to a steep peak at resonant frequency Fr. However, the impedance of the circuit decreases rapidly when the frequency is changed above or below the resonant frequency. Circuit impedance ZR equal to L by CR. At parallel resonance, the circuit impedance ZR is equal to L by CR, where ZR is the circuit impedance in ohms, R is resistance in ohms, L is inductance in Henry, and C is capacitance in farads. 2. Circuit current. At parallel resonance, the circuit current or the line current is very small. The circuit current I is given by the formula I is equal to applied voltage V divided by the circuit impedance ZR. Circuit current I equal to V by ZR, where I is current in amperes, V is voltage in volts, and ZR is circuit impedance in ohms. As the circuit impedance ZR is very high, the line current I will be very small. 3. Quality factor. The resonance curve of a parallel tuned circuit must be as sharp as possible to provide selectivity. The sharp resonance curve means that the impedance falls rapidly as the frequency is varied from the resonant frequency. The smaller the resistance of the coil, the more sharp the resonance curve. A small resistance consumes less power and draws only small line current. The ratio of inductive reactance and the resistance of a coil at resonance becomes a measure of the quality of the tuned circuit. The ratio of inductive reactance of the coil at resonance to its resistance is known as quality factor or Q factor. Quality factor or Q equal to XL by R equal to 2 pi FR L by R. Advantages of tuned collector RF amplifier. The advantages of tuned collector radio frequency amplifiers are: 1. Small power loss. A tuned parallel circuit uses reactive components L and C. Consequently, the power loss in such a circuit is quite low. 2. High selectivity. A tuned circuit has the property of selectivity, which can select a signal of a specific frequency from a large number of other frequencies. 3. Small collector voltage. A tuned amplifier stage requires only a small collector supply voltage due to the lower resistance in the parallel tuned circuit.
Thank you very much for taking